Well, I can feel fame and fortune rushing into my apartment as we speak, because already I'm getting people wanting shout-outs. I tell you what, you get me to 50 subscribers, and I will do all I can to shout out to those who let me know they want to mention in each of these videos. A little bit odd, but we'll see what we can do. Maybe a Twitter feed along the bottom. Anyway, welcome to Linear Relations Intercept Form. Yep. In the previous lesson, I'm pretty sure I talked about the idea that there was the gradient form and the intercept form. We've already talked about the idea of intercept and gradient, but let's just recap the important parts of the lesson. So we will put on our important language. Hopefully by the end of this particular short video, we'll have intercept, vertical, horizontal, and gradient all down pat as part of our learning. In our last lesson, we were talking about the idea of straight lines. And so what is a straight line? Well, yep, pretty much. It's a line that can, well, we decide to go vertically like that, or go down like that, or, well, I suppose there's any number of lines, and I could be drawing these forever. But two of the lines I'm interested in the start of this is this horizontal line and this vertical line. Nope, not even close. Not even close. Just go with the flow. That's a vertical line and we'll just deal with it. So we got this horizontal line and vertical line, and I think we decided, looking at the ideas of gradients previously, then a horizontal line can be described as having a gradient of equal to 0, and the gradient here would be equal to infinity, or undefined on our fabulous CAS calculators. These gradients here would have a value given to them, which we would effectively find by looking at our vertical and our horizontal movement and using the idea of rise divided by run. Well, that's a basic introduction, but how would we describe a straight line? Do they have equations? Well, actually, as it turns out, they do. Let's look at the following vertical line. Right? If we have a look, I've even very helpfully put that it's a vertical line. You know, the ends to my helpfulness are just no start. Anyway, so we have a vertical line. Now, if we look at each of the coordinates, we'll notice that across the way we say that this line is going through the point 5 on the x-axis. So it's going through the point 5 on the x-axis. And if I was to choose 4 coordinates and find the values, plot their values, write their values, what do we notice? Well, we notice we have the points 5, 1. We notice we have the points 5, 2, and 5, 3, and 5, 4. Do we notice anything that happens to be the same? Well, yeah. It would appear that all of these values are the same. All of them seem to be a 5. 5, 5, 5, 5. Well, what does that mean? Well, if I was to actually talk about that in language, I would say, well, all my x values are 5. And lo and behold, there we go. That's how we actually describe that vertical line. We actually say it has the equation x equals 5. Why? Just as I said, all the x values here are 5. And if we look at our diagram, well, all of our x values are indeed 5. And the line passes through 5 here. Now, that seems fairly sensible when you have a diagram in front of you, but when you're in the middle of an exam and you've got no idea, and you have a graph presented to you on a bit of paper that has a vertical line and that goes through 6, well, you're going to go, right, it's going up. Lines that go up are y, and so you're going to have y equals 6, and you're going to feel very impressed with yourself because you've got the answer right, and undoubtedly you will get a little bit upset when the teacher goes and does a little kiss all over your work, or rather in that case a rather large kiss. Alright, why? Because remember, maths is a big fat trick. Yeah, it's there to try and confuse you. That's my overriding idea. Just remember that a line that goes vertically up passes through x equals 5. It passes through the point x equals 5, and that then is our value for our equation. Alright? Yep, I know, you're probably sitting there going, but hold on a moment, that doesn't fit. Y equals mx plus c. Well, yep and no. That's a discussion for another time. This is just one of those, I suppose, special lines, and we all like to be special. What about a horizontal line? Well, as if by magic, the shopkeeper did appear, and there is an example sitting right in front of you as a horizontal line. Well, yep, the horizontal line in this case is going through the value of 3. If we look at our coordinates, we have 1, 3, 2, 3, 3, 3, and 4, 3. Oh, hold on, pretty much like the last time. What do we notice? Well, yep, all of these values, 1, 2, 3, 4, and in fact all of them along that line, all have the same thing in common. What do we notice? Yup, we notice that all of those last values are the same, and because the last values are y, then, yep, I suppose it goes without huge amounts of explanation that the equation of that line is given by y equals 3. Yep, because all of the y values are 3. One of those things I'm afraid you just have to remember. Sometimes drawing it out can help, other times just committing it to memory is one of those special moments. So we dealt with horizontal and vertical lines. We talked about in a previous video that we have the equation of y equals mx plus c, and so y equals 3x plus 6 would be a line that we could draw a quick diagram, and we would know that this thing crosses through 6 on the vertical and it has a gradient of 3, so up and across and do a dot, and up 3 and across 1 and do a dot, and we draw the line through that, and you know, once again our teacher, who is delighted with our progress, gives us a tick and a little smiley face because we're awesome. And yeah, so that was our gradient form. But again, maths being a BFT means that we actually end up in a situation where they can try and confuse us. They may write it in a different form. So if I had this written as y minus 3x equals 6, it's exactly the same graph, but it's just written in a different way. They've moved the 3x to the other side, and I've got y minus 3x equals 6. Well, as it says over here, that is called my intercept form. Why would that be called my intercept form? Well, it turns out that actually it allows us to draw our graph really quickly because it uses a bit of information. Now, there's a bit of a background learning. If we look at our axes and we look at them across, this shouldn't be particularly new to you, but we have the idea, we know that this is the y-axis and this is the x-axis. But they're actually called other things as well. This y-axis has a different name. What do we know about all the x values up this line? Well, if we go back to our previous part of the video, we know that it goes through 0. It goes through the point where x equals 0. So the y-axis can be written as x equals 0. All the points up that line are where x is equal to 0. So what about this line here? What about the x-axis? Well, once again, the x-axis is a horizontal line that goes through 0 for y as well. So hopefully you'll see that that can be written as y equals 0. So all the lines up here, all the points up here are where x equals 0, and all the points along here are when y equals 0. So that means I can maybe try and find intercepts. It says something about intercept form here. Well, yeah, that's pretty much what we do. So, using that information where x equals 0 and y equals 0, how is that going to help me try and graph? Well, one of the great things about the number 0 is if you multiply by 0, what happens? Yep, you get 0. Or things start to, quote, disappear. Unquote. So let's make the doodles I've currently been working on disappear and go back to our original question. So, right, we've got 2x plus 3y equals 6. And we know that to find values on my vertical part of my y-axis, I can let x equal 0. Well, that's nice, because if I let x equal 0, then 2 times 0 becomes 0, and actually that whole thing disappears. This, if I multiply by 0, actually disappears. And what does that leave me with? Well, yeah, it leaves me with 3y equals 6, or y is equal to 2. So hold on a moment. When x equals 0, you're telling me that y is equal to 2. Well, isn't that a coordinate? Sure is. So actually, I'm going to write that down. That actually, that's a coordinate that must fall on this line. It must be 0, 2, must be one of the coordinates on that line. Well, that's letting x equal 0. What happens if I let y equal 0? Well, let's write down the equation again. Well, if y equals 0, then 3 times 0, that's this thing here, obviously becomes 0. And yeah, that now disappears. So what do I get? I get 2x equals 6, or x is equal to 3. So you're now telling me that when x is equal to 3, y is equal to 0? Yes. So you've actually just found a second coordinate on that line. You've got another coordinate which is 3, 0. I love multiplying by 0. It is amazing. From 0 to hero. Sure, that's probably copyright, but we'll give it a go. Well, what does that have to do with the price of fish? Well, now we can use this idea to draw a graph. Oh, and as if by magic, a axis appears. I'm almost getting good at this now. Right, so let's see. We need to plot some coordinates, so we'll choose a nice revolting colour to try and draw that. Well, we've now decided for the equation 2x plus 3y equals 6, we have these two coordinates, 0, 2 and 3, 0. So let's draw some points on my axes, 1, 2, 3, and let's draw some points across, 1, 2, 3, and not forgetting the origin, or the origin as some I want to call it. And let's do some plotting of some points. So I've got 0, 2, which is 0 across and 2 up. There's my kiss. And I've got 3, 0. That's my kiss. And actually, and I'm going to apologize now, there is the equation 2x plus 3y equals 6. All I needed to do was plot 2 points. And I used a nifty trick that x equals 0 on this line and y equals 0 on that line. Wow. So actually putting things into intercept form can actually really help us. If you remember, if we were to go back to our previous part in the video, you generally had to draw 3 points. Open to problems, open to mistakes. Here, just 2. So having now decided that we like the intercept form, let's ramp up the complexity and see what happens if we get a complicated question. So the question now states, express in intercept form the equation of the line which passes through the points 3, 6 and 7, 12. Right, well, they've given me 2 coordinates. That's not a problem. As we know from our previous video, 3, 6 and 7, 12, I can do this. What am I trying to find? Well, to do the equation of any line, I need m equals and c equals. These aren't intercepts, by the way, so it's not that I can just go straight onto my graph and plot them and find my equation. No, I'm afraid we have to do a little bit of work. I need to find m and I need to find c. Well, how do I find m? Same way as we've been doing it in previous work. I know that m is equal to the change in y, so that's the 12 minus the 6, divided by the change in x, which is 7 minus 3, and so 12 minus 6 is 6, and 7 minus 3 is 4. Ooh. Well, let's cancel that down. We're going to end up with a fractional gradient. We're big enough to cope with this, not a problem. So, easily now, I have found my m is 3/2. How do I find my c? Well, to find the intercept, I need to go back to my y equals mx plus c. And what do I need to know? Well, I know m is now 3/2. I'm trying to find c, so that means I need a value of y and x. Well, of course I can find y and x because they're tricking me. A y and x value is found through a coordinate. So, y equals 6 times x equals 3. I've got a fraction times a whole number. Well, just for simplicity, let's turn that into a fraction because I know the best way to multiply fractions is by doing top numbers multiplied by bottom numbers. Right, so I've got 6 equals 3 3s are 9/2 plus c. So c becomes equal to 6 minus 9/2, which is 3/2. Yay! I now have my c. My c is 3/2 as well. Bit of a fluke that m and c are the same, but we'll work with it. Well, having done all of this calculation here, I can now write my equation as y equals mx plus c. I know my value of m is 3/2, There's my x plus my c, which is 3 upon 2. And there's my answer, isn't it? No. Why is it not? Because the question stated quite clearly that your answer had to be in intercept form. Intercept form, remember, is where you have y and x on the left-hand side and the number on its own. Well, we can do that. That's easy enough. Right, we've got fractions. How do we get rid of fractions? Well, we know that to get rid of this divide by 2, what do I do to the whole thing? I multiply the whole thing by 2. So, 2y is equal to, 3x plus, hold on a moment. If I multiply by 2, not only does it get rid of that divide by 2, it's going to do the same to the thing there. Plus 3. Yes, we like, because I can now suggest that if that 3x moves over here, I get 2y minus 3x equals 3. Yep, we like. And so now I can happily write the answer to my equation is that the answer in intercept form is 2y minus 3x equals 3. Hope you found this interesting. Look forward to seeing you again.